So first I'm going to try to give a mechanical breakdown. So here's the drone of focus. It's the AUVSI hexacopter. It looks like that. This whole thing's put together with carbon fiber tubing. You can see this carbon fiber tubing is a natural finish twill with 0.03 inch wall thicknesses and 1 inch ID. And it's all put together with nylon bolts. So that this black nylon portion right here is a nylon bolt, and that saves weight. We use aluminum nuts. This is that also saves weight, and this is a lock nut. You can notice that little the extra portion on the nut that holds a piece of nylon in it to hold onto the nut so it doesn't vibrate off. Then we use neoprene-backed washers, and the reason for this is to reduce vibrations, to be kind to the 3D prints, and also, yeah, just to make sure we maintain that squeeze pressure. Yeah, those are bolted up to common torques, and that's how we maintain like rigidity in the sky without all the screws just vibrating off. And you can see that there are 6 screws just holding that one joint together with that one motor, and the motor wires, travel from there to that ESC, and then from that ESC into the flight controller. Okay, so the design is completely composed of triangles, and that's because triangles are the strongest shape and they take the least amount of tubes to make. And every single piece on this drone is structural, including these little bars down here. Without those, this joint would just kind of spread apart. Like it would go from this to that, and with very little force. And that's not objective because we're going to put some weight on this in the end. Okay, so that's the main mechanical breakdowns. There are tiny little portions. Like we use connectors that go on the outside of the tubes, not on the inside. That's because we want those connectors to be stronger typically, and by moving them to the outside we get a higher moment of inertia. And then this motor plate here, this is actually a separate 3D printed piece that's just bolted onto the top, and then the motor is bolted onto that piece, and then this piece has screws that are against the flat surface of this, so the screws can't vibrate out. So the motors are typically the things with the highest amount of vibrations. So if we were not careful with that, then the motor would vibrate itself off. Next, we're going to quickly talk about the electronics. Okay, so in all the corners you can see motors. These motors spin. They are 2-phase brushless motors. What that means is they have 3 wires coming out of them. Each set of those 3 wires will go to an individual ESC. So there's one ESC for each of the motors. And ESC stands for electronic speed controller. So that basically just takes in power through a red and a black wire, and then it takes in signal through a signal wire, which is white typically, and a ground, which is always black. Each of the ESCs is connected to the batteries through this power strip here, and you see that all the ESCs come together, 3 on this side, 3 on that side, and they all combine at this point to this XT60 connector. And this is just a power module for the Pixhawk, so it knows how much current is going through this connection right here, and what the voltage is, and it also uses this power board to supply itself power. Okay, so that Pixhawk Cube I mentioned is the flight controller. That's at the heart of everything. I'll give you guys a close-up of that. But basically, what you want to know, the main parts that fly are the motors spin because the electronic speed controllers tell them to, and the electronic speed controllers spin them at the speed that the Pixhawk tells them to. Now let's take a deeper look into that Pixhawk. Okay, so this is the Pixhawk Cube, black 2.1. So these cubes are just the internal inertial measurement units, and these cubes can be swapped out, and they have different colors based on what kind of sensitivities you need. Okay, but this is just the cheapest version, and that's all we really need as a club. We haven't yet reached the maximum potential of this, so we're still limited by ourselves, not the controller. The controller has a great number of inputs. And you can see, I'll take this cable off for a second. Okay, you can see that we got a GPS port, which I just unplugged, another GPS port, a telemetry port, a CAN port, another telemetry port, and an analog to digital converter, and a I2C. So the I2C can connect a lot of sensors, so can CAN ports. And that's useful if you want to run an extra barometer, or if you want to run another GPS, then you're going to need to use those ports. And you can also run airspeed sensors, any kind of sensor you like off of the I2C. I think it's up to 64 addressable devices or something like that. So you can run off a lot of different devices off of one port. Okay, so every single PICSOC comes standard with a buzzer typically, and this is just a piezoelectric buzzer to make noise. It tells you what the PICSOC's thinking, and it'll either make happy noises or sad noises. There's also typically a GPS in the system, and this one has an integrated safety switch, which is also a common feature of the PICSOC. So the safety switch stops power to all the motors. So without initially pressing the safety switch, none of the motors will be powered. So it's just a safety precaution, obviously. We have the programming port, which is a micro USB, and there's another one on the side, but I would suggest not using this one because it typically gets worn out pretty fast if you are not too careful with it. As we can see, there are 6 channels on the main out over here, and these 6 channels all go to one of the ESCs. So minus this one on the far left over here, which is the receiver, all of them go to ESCs. So actually, where is the receiver? Anyways, so by this channel, we'll go to ESC number 6, ESC number 5, 4, 3, 2, 1, and all those ESCs are connected by these power cables here, and this is just the power distribution segment. So this cable and this cable are what we call power distribution, or PDB. Like I said, this is a current and voltage sensor, so that's just what we call a power module, and that's the entire overview of this system. So the PICSOC reads the data from the GPS, which it gets to the GPS 1 port. It takes in new commands through the micro USB port. It sends out information about its current status through the piezo buzzer, and we can control it through the receiver, which is currently not connected. The receiver should be here, but it is currently not connected, like I said. And now it just go to RC in. RC in is what receiver is. So, anyways, that's it for the PICSOC overview, and I think we're pretty much done here. Hey guys, so I figured a good way to teach you guys about drones was just to tear one apart. So I've got this beautiful drone right here. I've got a nice pointing tool for me, so I can point to things for you guys. I got a nice 2.5 millimeter hex head screwdriver, and I got some needle nose pliers, and that's all I'm going to need to be able to take this apart. So first off, anytime you're working on your drone, please take off your propellers. Luckily, I have some quick change ones, so all I need to do is push on the trailing edge, and that's the side that doesn't go into the wind first. The leading edge goes into the wind first, and then I can take off my propellers. I'm just going to really quickly do that. Okay, awesome. So now I have a de-propellered drone, and I have my 4 propellers, 2 clockwise, 2 counterclockwise, and I have my 4 prop nuts, 2 righty-loosey, 2 lefty-loosey. Okay? I'm just going to put those to the side for now. Now we got our main body of our drone here. First thing is, we got a top plate, and we got a bottom plate, and we also have this flight stack in here. Let me see if I can focus. This flight stack in here. Okay, so there we can see the USB port. We can see the reset button for the flight controller, and we can see the SD card slot for the DVR, which is right there. And I'm just gonna put this thing down, and I'm gonna take it apart so I can get a better close-up look at those things. So now I'm going to take it apart just to see if we can get a better look at it. So, one screw down. So now I've taken off the top plate. I'm just going to put these screws aside. These are all 10mm M3 screws. So I'll put those there. I'll put my prop nuts, which I took off, which is always a good idea to take your propellers and prop nuts off before you start building, obviously. And so there's all my spare parts. So now I'm just going to pop off this top part. But I got to be a little careful because the receiver antennae are going through it. So there's one receiver antenna. Here's another one. And now we just have the VTX antenna, which is on top. And I'm just going to, that's plugged in with an MMCX connector. An MMCX connector is just a little tiny coax connector, and that's for the video transmission module to transmit radio frequencies. And now, anyways, we see the insides of the drone now. So I'm going to take the camera into my hands and give you guys a closer look of this. Actually, first I'm going to take off these nuts, these nylock nuts, these aluminum nylocks. I'm just going to unscrew them with a wrench, and I'll be right back. So now I just got to get access to these screws down here and loosen up these nuts, which should be pretty quick. Take off 4 of them. Okay, 1. So first, we have the receiver on top. This is just an XM Plus. It runs S-Bus. We can see that it's double-sided sticky taped to this little PCB plate that came with the flight controller. So I'm just going to carefully take that off. With one hand, which is kind of difficult. Says every YouTuber ever. Okay, so underneath of the top plate is a VTX. Okay, that's the Infinite AKK DVR VTX. So we got it built-in DVR. We can see up here, we got the positive, we got the negative, we got the smart audio, which is typically a green wire. So now I'm just going to carefully take off this TPU camera mount, okay? And I'm going to set up the camera back in the original position. Okay. So basically what I'm going to do is I'm just going to pop off this camera mount, but I have to be really careful because it has a really short connector. So I'm just going to unconnect the connector first, and then I'm going to pop out the camera mount. Okay. So now we see a RunCam Nano 2 in there, and that's just a TPU printed, pretty much solid, except for a little bit of squish there. Camera mount with adjustable angle capabilities, so you can put your camera in the angle. Okay. So back to the drone. So we got this beauty here, which is Infinite AKK DVR VTX. We just ripped off the XM Plus here, and hopefully that doesn't get stuck again. Okay, good. And then I'm going to strip the DVR VTX off. So that's just, these are on screws. So now now we can see the flight controller. Okay, so we got the flight controller right here. This flight controller is an F7 flight controller. We can see that it takes camera inputs here, and it takes VTX inputs here. This is the forward arrow, so every flight controller has an orientation, and this one's oriented forwards. In this case, is forwards. You don't have to always mount them forwards to be forwards. You can mount forwards to be backwards, and you just have to tell it in the software which direction forwards is. So as you can see here, these little yellow things are vibration dampers, and those all help damp out high frequency oscillations that are reaching the IMUs, this is an MPU 6000 right here, that little chip on that board, and that's just how it does all of its gyroscope and inertial measurement, and that's how it tells if it's rotating or if it's upside down or if it's accelerating forward. Right here we have that micro USB, and then if I were to take this off, which also involves taking off 4 little standoffs, if I were to take this off, then underneath that we would see the ESCs. And this is a 4-in-1 ESC, so basically there are 4 ESCs in this tiny little square here. And the power input comes from here. It goes to the ESCs. It's distributed between 1, 2, 3, 4 motors, okay? And those 4 motors all receive those 3 wires that we were talking about. And you can see it pretty easily here because there are 3 black motors for every counterclockwise motor and 3 red wires for every clockwise motor. And right out of this ribbon cable here is, or not ribbon cable, just cable, is all the channels of the motors. So that's those 4 white wires there. 1, 2, 3, 4. The blacks are grounds, okay? The red is the battery voltage, so you got to be really careful because most of your electronics in here will take 5 volts or 3 volts, but they won't take battery voltage typically. So like the VTX is the only thing that will take battery voltage typically. But you don't typically want to use the battery voltage on your VTX because the inboard current modulators and voltage modulators are not that great, so it'll cause breakup in your video feed. But anyways, so this is just an RGB LED in the middle, and we got a current sensing wire and a voltage sensing wire, and from our ESC. So this is a pretty nice ESC, and that sends all that information through that ribbon cable up to the flight controller. And the flight controller says, "Oh, I understand. You want me to go forwards, right?" And it changes the motor outputs so that it can do the desired task. So basically, now I'm just putting everything back together, and it all fits as layers. Layers of little electronics boards. And I put the ESC, which I never took off, and then I have the flight controller, which is the equivalent of a PIXOX system. And then I have the VTX, which this is the same no matter if you're using PIXOX or Betaflight. This is a Betaflight system. And then I put back on the receiver. And everything needs a receiver. The receiver is how it talks to your sticks, your control communication. So that's a necessary component. I forgot some standoffs, so I'm going to have to take everything apart, which is not atypical of me and the RC hobby. Put these babies back on. Awesome. So that's all there is to it, really. Not that much, honestly. And all systems are the same. If you understand this tiny little drone, which is it could fit in my hands, then you can understand massive things like the ones we looked at earlier.